All right, let's look at these true false here. So starting with the first one, vertical angles are never adjacent. That one is true. Vertical angles are always opposite from each other, not side by side. So how'd you do? Supplementary angles are a linear pair. This is false because supplementary angles do not have to be adjacent, but a linear pair must be adjacent, creating a straight line. So no, supplementary angles are not always linear pairs. So this one is false. Number C, if the diagonals of a quadrilateral are congruent, then it's a rectangle. True. If the diagonals of a quadrilateral are congruent, then it is a rectangle. The diagonals of a rhombus are never congruent. False. This is a special case of when a rhombus has congruent diagonals, is when the rhombus is a square. So the diagonals of a rhombus are never congruent. There is one special case where it is. The altitude of a triangle cannot be the side, so I put this picture over here. It can be the side sometimes. So it may be a side or it may lie outside, so just FYI, that one's false. Consecutive angles in a parallelogram are supplementary is true. We know that opposite angles of a parallelogram are equal, so the sum of any two adjacent angles are equal to 180. So any two adjacent or consecutive angles are supplementary. That one is true. And then finally down here, the way I like to think of these ones that are sometimes, always, or never is if you can think of any one example of when it can happen, then it's a sometimes. And if you can never think of a time when it wouldn't happen, then it's probably an always. And a never would be obviously the opposite. So vertical angles are always congruent. That is true. That's by definition of vertical angles. An exterior angle never equals the side of the inside triangle. Corresponding angles are sometimes complementary. So I want you to picture that if you had two parallel lines, I already copied and pasted this here, and this one was 45, and this one was 45, then those corresponding angles are complementary. That's the only time it can happen. A bisector is sometimes perpendicular. So we've been working a lot with perpendicular bisectors, but we don't have to have it perpendicular. Like if this is a line and we have a perpendicular bisector go through the middle, okay, that's one thing. But what if the line goes like this through it? It's not perpendicular, but it still cuts it in half. So a bisector is sometimes perpendicular, not always. Opposite sides of a square are always parallel. After a rotation, corresponding sides of an image and pre-edge are sometimes parallel. You can Google that and see some images. After a reflection, corresponding sides are sometimes parallel. You can Google that and see some images. After a translation, segments connecting the image and pre-image are always congruent. Google that and see the image or look at our class notes. The altitude of a triangle is sometimes a line of reflection when there's an equilateral triangle. So let me show you this. So if you picture an equilateral triangle, drawing in the altitude of this would be a line of reflection, and it would form that 90 on there. So that would be the sometimes. Okay, so hopefully you got some of those right, thinking of them on your own.